Now we are solving question number 10 of this P3 paper for the year 2023. The polynomial x cube plus 5x square plus 31x plus 75 is denoted by P of x. Show that x plus 3 is a factor of P of x. Since x plus 3 is a factor of this polynomial, so you can directly write P of minus 3 equal to minus 3 whole cube plus 5 into minus 3 whole square plus 31 into minus 3 plus 75. This thing is equal to minus 27. This is plus 9 5s are 45 minus 93 plus 75. And that factor is equal to 0 there. So this shows that x plus 3 is a factor of this P of x there. It is part A of that. Show that z is equal to B part minus 1 plus 2 root 6 iota is a factor of P of z equal to 0. So we can make this P of x in terms of P of z, that is equal to z cube plus 5z square plus 31z plus 75. Now we are going to solve it with respect to this. We know there are many methods, but we can apply it here. Simplest method. We know that polynomial of z is identical to z plus 3 because x is going to be replaced by z into the quotient of z. So for the quotient of z, we are going to find it out. P of z is equal to z plus 3 into az square plus bz plus c. Or you can use the other method, which is by the simple division, that is z cube plus 5z square plus 31z plus 75 is going to be divided by z plus 3. So it should be equal to z square. So z cube plus 3z square. This is minus, this is minus, this is going to be cancelled out. So it should be 2z square plus 31z plus 75. So 2z square plus 31z plus 75 is going to divide it by z plus 3, then it should be 2z square plus 4 3s are 12z, sorry, 2 3s are 6z. Again, it will be subtracted. This will be cancelled out. 31 minus 6, 25z plus 75 plus 25. So it should be written as 25z plus 75. So P of z is basically equal to z plus 3 into z square plus 2z plus 25. Now z is equal to minus 3 for the first factor, and for the other two factors we can use the quadratic formula for this portion. So z is equal to minus 2 plus minus 4 minus 100 over 2 into 1. So that is minus 2 plus minus minus 96 over 2, which is equal to minus 2 plus minus 16 into 6 with the minus sign over 2. This thing is equal to minus 2 plus minus 16 square is 4, 6 into iota over 2, as iota square is equal to minus 1 in the complex number. So z is equal to minus 1 plus minus 2 root 6 iota. So they have shown it the two roots values of that, minus 1 plus 2 root 6 iota and minus 1 minus 2 root 6 iota. But in the part B, they have shown that you have to show that minus 1 plus 2 root 6 iota is the root of that equation. So here z is equal to minus 1 plus 2 root 6 iota is the factor of that polynomial, which is going to make it equal to 0 for that factor there. There are other methods also there that you can use this in this equation and you can get it answer equal to 0. Now, third method, C. Hence, find the complex numbers z, which are the roots of this equation p of z square is equal to 0. Since polynomial of z is equal to z plus 3 into z square plus 2z plus 75. So polynomial of z square, it is z square plus 3. We replace everywhere, wherever it is z, it is now replaced by z square. It should be equal to z4 plus 2z square plus 75, and this thing is equal to 0. Now you are going to make the factors of this one, that if z square plus 3 equal to 0, then z square is equal to minus 3, or z square is equal to 3 iota square, or z is equal to plus root 3 iota and minus root 3 iota are the two answers of this first factor when z square plus 3 equal to 0. Now for the other factors, for the second factor, which is z4 plus 2z square plus 75 equal to 0, it is a quadratic equation in terms of z square. And we have already calculated the values of z equal to -1 plus minus 2 root 6 iota there. So we can replace it like this, that z square equal to -1 plus 2 root 6 iota is the one root, and the other root of that equation is -1 minus 2 root 6 iota is the other root of that equation there. But we are going to find out the value of z there. So we know one thing, that z equal to x plus iota y. So z square is equal to x plus iota y whole square, which is equal to x square plus 2 iota xy plus iota square y square, or that thing is equal to x square plus 2 iota xy minus y square, or it is equal to x minus y square plus 2 iota xy is the value of z there. So you have going to replace it one by one for the two roots we have already calculated in this part there. So first of all, x square minus y square plus 2 iota y is -1 plus root 2 root 6 iota. If we compare the real part, it is x square minus y square, it is -1. So it will be x square minus y square is equal to -1. Let's say it is equation number 1. And then imaginary part, that is 2xy is equal to 2 root 6. So 2 and 2 cancel. So xy is equal to root 6, or y is equal to root 6 over x. Let's say that is equation number 2 there. Now we put 2 into 1, then it will be x square minus y square, that is 6 over x square is equal to -1. If we take the LCM, x4 minus 6 is equal to minus x square, or x4 plus x square minus 6 is equal to 0. We suppose this x square is equal to p, then x4 is equal to p square. So this expression will become p square plus p minus 6 equal to 0. Just factorize this part. It is p square plus 3p minus 2p minus 6 is equal to 0, or p plus 3 into p minus 2 equal to 0, or p is equal to -3 and 2. But p we have supposed it equal to x square. So if x square is equal to -3, or it is equal to 2. But -3 is not possible because x we have taken it as a real component to that. So x square should be equal to 2, then x will be equal to plus minus root 2. Then the y value is equal to root 6 over plus minus root 2, that is equal to plus minus root 3 there. Now, the two roots of this equation of -1 plus 2 root 6 iota. So one value is z is equal to x value is 2 root plus root 3 iota, and the other value is minus root 2 minus root 3 iota. So these are the two values of the second part of that question, where the roots of that equation equal to -1 plus 2 root 6 iota there. And then the third root of that z square equal to -2 minus 2 root 6 iota. Again, we apply the same procedure for this part. let x z square is equal to x square minus y square minus plus 2xy equal to minus 2 minus 2 root 6 iota. Now comparing the real part, x square minus y square is equal to minus 2 and imaginary part as 2xy is equal to minus 2 root 6. 2 and 2 cancel. So y is equal to minus root 6 over x there. So replace, let's say it is 3, it is 4. Now put 4 into 3. It should be equal to x square minus 6 over x square equal to minus 1, which is the same equation we are getting in this part there. So x values are 2 there, which is minus 3 and 2, but minus 3 will not be accepted because x is the real part. So it is having the value of 2 there. X square is equal to 2, then x is equal to plus minus 2. So y will be equal to minus root 6 over square root of 2 with plus minus. So that is equal to minus plus square root of 3 is the value of y there. So the answer for this solution of this problem, where the root of that equation is equal to minus 2 root 6 iota, then one root will be equal to root 2 is the value of x, and y value is there minus 6 over root x. So that thing is equal to minus root 3 iota. And the other root of that equation is z is equal to minus 2 root 2 plus root 3 iota there. So there are 4 possible answers for this solution, which are going to be written like this, that z is equal to plus root 3 iota minus root 3 iota and then 2 root plus 3 root iota, then minus square root of 2 minus square root of 3 iota, and then root 2 minus root 3 iota and minus root 2 plus root 3 iota. So these are the 6 possible answers for this question, where P of z square is equal to 0 for this solution there. So this is the last question of this. I hope that you have understood all these questions we have solved from 1 to 10 of this paper P3 for the year 2023 for the variant 3.1.